Good afternoon. Sorry, it's a little noisy in here.
Hi, how are you doing?
Good. How are you?
Well, hanging in there, it's Monday. Yeah. I have to decide to put down one of my dogs this week. I'm
Oh
not
no.
ready. Yeah, his cancer has gotten really bad.
Oh,
And he he he's a very large dog, so
mhm,
he's not able to move around as much. Um, I'm still not ready.
mhm.
So, I'm gonna pay for someone to come and help him, but I'm trying to hold on to him as long as I can. He's 11.
No,
But
definitely.
yeah, I'm his sister is, same litter. She's doing well, but she has lumps. It just she's not in the bad condition. He ate half dog food and half regular food, and so
Mhm.
So he had a very large tumor on his rib cage, and I
Mm.
decided not to go through with surgery. I almost did, but it was so traumatizing to him that I pull out the last minute when I was at VCA. But
Mm.
yeah, you probably hear him drinking water right now.
Yeah.
I sit next to the water bowl on the door, so he occasionally wants to go outside and yeah, go on, buddy. Yeah, so it's been tough, but the usual at the Wins household.
Yeah.
How are you doing?
Better-ish. Things are a little easier now that I have my computer set up. But
Oh,
what was I gonna say? Yeah, we've been pet owners since I was a little kid, like dogs
mhm.
especially, and we've lost a couple during either to illness or one of them actually died while we weren't here. He
Oh,
got out of the backyard, but he stayed at the front of the door. Unfortunately, a Rottweiler got loose and he protected the house.
oh, and they got in a fight.
The neighbor broke it
Oh,
up, but by the time he did, we came back and he was already like going. He didn't make it to the vet.
oh, I'm sorry about that. It's always hard to lose a pet. Yeah,
Hmm.
I've always had animals since I was a kid. Um, but these are kind of like my baby since, I started moving back here. I left my other dog in San Diego, and she's older now. I don't know if she's still alive or not, but um, you know, I used to live in San Diego, so my ex-boyfriend kept her, and he wanted her. So I decided I wanted to bring her up here, but so I adopted these guys from Apple Valley.
Hmm.
They were kind of just, they first people were trying to sell them, and they didn't. I guess nobody wanted these two, so I drove up there and I got them, and you know, so they've been with me. 1 second, okay? I'll be right
Hmm.
back.
Okay, no worries.
Just gotta make sure he doesn't fall.
Oh yeah.
You can do it. Just go on. Sorry, buddy. Good job. Good job. Sorry about that.
Oh, that's
Yeah, my
okay.
dogs my dogs fell a couple of times, so just want to make sure. Even his legs are still swollen.
Oh,
Yeah. All right. Since it's 2 o'clock, let's talk about what we have in store for us today. So we have some exciting stuff that we're going to learn about graphs. Um, This second part is on network monitoring, but I wanted to hit graphs first. So, and this works, really well in Python and using the library that's shown in your notes. So let me get my notes open. Um, 1 second. Okay, so let me go into screen share. So in this week, we're going to talk about Unit 8. And Unit 8, I had released the assignment in the notes. And then when we work on the lab this week, it's going to be close to some of the exercise we are previewing today. So you can find the notes in Unit 8 module along with the assignment and the lab. A lab I will actually release later today or tomorrow morning. Okay, so in the assignment, to start, let's touch on the notes area first. So last week we talked about SNMP. The challenge with some of this is that we're unable to use Cisco Viral, and GSM3 doesn't always cooperate like how we want it to go. So what we'll do is we are going to look at how we would map out a network, and to kind of tie back to what we were talking about last week is when you're managing a network, not only that you are looking at your existing traffic that's coming in and leaving your network, you're also looking at the performance of your system, like CPU load, your memory usage, and all the appliances have processor, and they have memory that would be used internally in the device. On top of that, you are going to manage your system via a server or some kind of controller. And often you will find that, working with the Python libraries, we want to use Linux systems. So this is why we see a lot of Ubuntu being used in the lab, so that way it kind of simulate what you would see. However, some of the library and the tools that we're using are actually compatible with Windows and Mac OS. So it doesn't, we should see that it is compatible with other type of operating system as well. So one of the things that we see is that when we're working with routing and switching systems, we would see that there are pollers in that devices are being queued every so often, like 30 seconds, or you can sync it every minutes or 5 minutes, etc. And that does take up a lot of the resources, as it mentioned. So as the devices are polled, they need to be responding, right? Especially when you're looking at routers. Routers always look for other routers that are neighbors. And the same thing with higher level switches. So what happened is there would be some form of request that would send out from a system. It would broadcast and it would ask for all the neighboring devices. Those neighbor devices would then respond and say, I'm here, I'm available, or this is the type of service. So with that, what you see is you see usage in CPU cycle. And then also in some packets, sometime you would see that packets need to be, the request needs to be replied or service. So for example, like web server, we would see some of that, right? Because in the HTTP server, it would actually need to confirm by responding to the request. So when a user access a web page or a website, before the web page could be loaded, the system, the client system needs to submit some kind of request or get HTTP. And the web server would then respond and reply to that request. And it is a multiple communication pipeline in that entire process. So you do see a lot of polars, and in SNMP, polars often by default they would query every 30 seconds. Just to check to see what systems are available, what kind of information it's acquiring from about that system, and that requires a lot of management overhead. So what we can do is we can take a look at how we can monitor the traffic efficiently, and using the pull and push model. So that way we would be able to push information to the device that's receiving this information, and then pull the information once it's pushed to be able to gather that and monitor those devices. Okay, so that is really the main approach in managing a lot of these systems are connected, and to make sure that they are in healthy status. So in the area of flow-based control, we often think of flow as in traffic flow. And basically, we're looking at packets and traffic information. And you got a little bit of this when we're looking at, the packets using SCAPI. And then in addition to that, if you're using network monitoring tool, aka network analyzer or sniffer, right, like Wireshark and other type of network sniffer, you would be able to look at the amount of traffic that's entering and leaving your network at a certain window of time, or doing it live through live monitoring. So we would use some form of management system, okay? And Cisco is proprietary to Netflow, and Netflow would work directly with Cisco devices. So if you're using other type of appliance, you want to consider other type of tool or technology that would be compatible with those appliances. And so we'll talk about Netflow, SFlow, and how to use Python with that. Now, keep in mind that not all monitoring devices would have time series data. So this is why it's important to really think about how you map out your network and the network design. So network topology is really important. It speaks a lot about security, physically and logically, on how you lay out your network. And also that will help us in monitoring our network with syslog, and looking at how we would bring in time stamp information in traffic and system access. So one of the things that we would touch on first is we are going to use network graphing technology. And so in Python, what we can do is we can incorporate the programming side to the flow-based model that allows us to really map out how all the devices are connecting, and the status of those devices using graph tool like GraphViz. And if you're familiar with my CIS7 class, or if you have learned discrete structure or some kind of graphing programming with C++ or another language, you will like this portion because you will be able to utilize libraries and tools to be able to simulate, right, your network topology, and each of your device will be nodes on the graph, and we can have directed or simple graph, or bidirectional um, components that will be connecting bidirectionally. So GraphViz can be used with Python wrapper to be able to show us the topology or the layout of the network. Okay. And so later on, we will touch on other type of tools and looking at network security logs. But just to touch on GraphViz, it is an open source graph visualization software. And it works with anything that you want to create a graph for. It doesn't necessarily have to be a network topology. Let's say that you want to graph out your flowchart for your program, or you want to graph out sales route, or you want to graph out, task flows. You can use GraphViz. Okay. So in the first question of our assignment, it asks for you to explain why GraphViz is used in network monitoring. How do you install GraphViz in a Linux system? So we can say that GraphViz is used to represent structural information as diagrams of abstract graphs and networks. And again, it doesn't have to be networks, right? It could be anything that you want to represent as structural information. It has important applications in networking, bioinformatics, software engineering, database, web design, machine learning, and visual interfaces for other technical domains. So I pulled this detail from GraphViz documentation. And to install GraphViz in terminal, you simply use sudo apt-get install GraphViz. But if you are using Windows machine or Mac OS, you can download. So let me show you. I had to close all the pages that I previously used here. So the information that I got for question 1 comes from the documentation, and you can go to graphviz.org. I believe I provided some link on your notes as well. And it might look something like this, right? And if you wanted to see other images of visualization for graphs, it can be any of these. Something like this, right? Math parse tree is an example. Linux kernel diagram, cluster, build systems, data structure, automaton, etc. So you would see a lot of different examples. Come on in. And you would take a look at how that would be used. So you can even use it for like family tree, etc. Okay, so many things that we can use this with. So going back to this, we can see that it represents information, right, in a structural format. And we can provide the visualization by graphing it. And in our case, we're looking at networks, like we would be able to represent each node and how they are interconnected. Like node would be your servers or your switch, your routers, etc. So importantly, what we need to see is that using GraphViz, when you install GraphViz, you would see that it has executable, and one of the main functionality is driven by dot. Okay. So now if you visit GraphViz, it talks about how you can use it, what you can use it for. So there are components to GraphViz, such as dot. And dot allows us to draw directed or simple graphs. Okay, like this. Okay, so that's one of the mechanisms that's in GraphViz. Or if you wanted to have it lay out a little bit differently, you can use needle. Okay. An example of that is shown here. Like if you wanted to put in relational diagram, it could be for your database, right? It could be for your software. And then we have FDP. Now keep in mind that these, using GraphViz, you can produce image files, right? And you can generate GraphViz file, which is the extension .gv. But ultimately, we want to produce an image, mainly a 2D image. And then if you wanted to make it a little bit more elevated, you would see something like this. So it has different functionality. Okay, if you ever try to use like one of those websites where it maps your information, right, from your system to other system, it would look like this. You would see a large scale of how your information flow from your system to different servers, right? Especially if we're looking at like social media type of information. Okay. And then circles. So today our practice exercises will be mainly with dot, but you have options to use the other sub tools that's built within GraphViz. Okay. So if we look at download, you would see that there are executable packages and it is released from Git. So in Linux, if you click on Linux, it tells you the packages that how to install for Linux. So if you use Debian or Fedora or Ubuntu, you can simply use the terminal. And as you can see, slightly different, but like, for example, in Raspberry Pi, you would do sudo apt install, and then in Ubuntu, you can also do sudo apt install. Compared to Fedora, you would do yum. Now, on the Windows side, we would see that there are different releases. Okay, so I tested these. If you download the executable, for example, like this, keep in mind that you won't have all the tools. Okay, so I'm gonna download and show you, because when you run the executable, make sure that you set up your path option. Okay, so I got a little firewall message saying that I'm trying to install. So we're gonna go ahead and click next. And then, check out the agreement. This is open source. So we're gonna go agree. So here is important, right? Because if you don't add the GraphViz in the system path, you will run into issues in running some of the things from Python. Okay, and even with that, you still have to modify some of the path in some of the later exercise, and I'll talk about that. So right here in this in this step, what you have to do is you need to select one of these options. Okay, this is for all the users, but if you only wanted to have it for yourself, you can select this option. And then now I selected this, but it didn't really put an icon on my desktop. But you should select this and this option, and then you're gonna go next. And then keep in mind that it's gonna put it in program files under GraphViz. So on Windows 10, it's a little bit different, that the actual path that it puts it under is under app, right? C, and then app, and then program files. But the traditional structure in the file system for Windows, it's going to be under this path. So if you need to set up environment variables later on, this will be the path that's default, unless you specify otherwise. Okay. And then you're going to click next. And then we are going to go ahead and click install, and it's going to finish. It's fairly simple. Okay, now if you download the other one, okay, which is a zip file right here, or the other options. So this one contains the complete set of tools. However, it's going to come down as a zip file, and it's 32-bit. So once you download the zip file, then you have to extract that zip file and put it in a location where you would be able to utilize it. Okay, and if you watch the tutorial online, right, I did look at some of the tutorial that are available to see which ones are good. So hopefully maybe link it to your Canvas shell. You would see that the version that's in the tutorial are a little bit older. So they kind of did away with the editor on this later version that you see here. So when you work with GraphViz, you can use any text editor, meaning that you can use Notepad, right? You can use, if you have like Sublime or Notepad++, you can use that. So you can write, and it's usually very short to graph things out, so it doesn't take that many lines. So you can write, you know, the things that you need, and then you would then save it as a dot. You would run it with GraphViz, and I'll show you how you can do that. Okay, so again, this is a zip file, and you have to extract it in order to utilize, and making sure that you link it, you set up the environment variables. But if you run this one, it doesn't have everything, but it does give you the option to set up environment variables. And so what am I talking about, right? If you've taken my Java class or set up environment variables before, so you can go to your system and then go to advanced system settings, and under the advanced tab, you would see your environment variables here, right? And then two things that you have to set up is you have to set up your user variables, right? That's going to link to the user application. And then you have to set up your path. So if you're not sure, you can go into here, click edit to see how I have one right here. Okay. And then also on this is the system environment variables, and that's important. So when it executes, it knows where the file is located for the executable through this path. Okay, so all the application that you install that is working on your system, right, would have some form of path. So now if you want to make a new one, you simply click new, and then you copy and paste the path in, okay, for the value and the link, or you can browse to it. If you are not sure, you can look at edit and you can see if it's there. Okay. So that would be where you would set up your environment variables. Okay, any question? Okay, so let's come back to the notes now, and let's talk about additional details that we need to know about GraphViz. So what are we doing when we're graphing this, right? So when you query your devices, right, from a controller system, you're basically looking at all the devices that are connected, which are neighbors. And so what we can do is we can use a protocol called link layer discovery protocol, the LLDP. And this allows us to really map out the active connected devices and their status. So in the illustration, it might look something like this, right? You have your routers, you also have your edge router, and then you have your servers connecting. Okay. Now this is coming from Cisco Viral, so it looks like this, similar to your GSM3, but the visualization tool that we're using is mainly for us to be able to obtain the data, right, from the devices and then put it into the GraphViz. Okay, so here it talks about the installation. Now, after you install, you can also install in Windows command prompt using pip, right? And pip3, you can do pip3 install GraphViz, and that would tie it with the Python that you're using. But with GraphViz, you're going to have the dot. And if you ever look into the bin folder, you would find .exe there. And this is what we're going to use to really do the directed graph and the simple graphs. Okay. So if you're using your terminal or your command prompt, you can also use pip. And with Python, what we want to do is we want to import GraphViz, right? Or the component of it anyways, when we write our program. So what I did was I gave you the dot guide here, okay? And then it came with this PDF, okay? So if you look at the dot guide, it talks about how we would use dot language, okay? And then the syntax behind the dot language. So the keywords that you would see is subgraph, digraph, edge, node, strict. Those are the keywords. So if you're trying to use identifiers, stay away from those keywords because those keywords mean something for dot. And so when you have the string, you can have any string in alphabet characters, and you can also use underscore and digit, but not beginning with digits. So the rule of thumb for variable naming or identifier naming, we want to stick with that, right? You can also use numeral values, and then you can use any double quote for string. And we wanted to treat it like if we're using HTML string, we can just enclose it with the bracket. Okay. So keep that in mind, and it's very similar to HTML labels. So the support language for dot is C++ style. Okay. So your comments is you can use block comments and comment option like C++. Okay. So if you use like the hash, that will be considered a line of output for the C preprocessor. And semicolon is to aid, and commas to aid to as separator or to really more on the readability. Okay. Any amount of white space may be inserted in between the terminals. So here it talks about like the syntax and how you would do it. So when we do a directed graph, you would use the arrow like this, the dash, okay, with the greater sign symbol. And if you use a double dash, then that's just non-directed graph, simple graph, okay? So when we say graph, that is for non-directed graph, a simple graph, just a line, no arrow. Okay, so we would use a double dash. If we do a digraph, that means it is a directed graph, and that would require the arrow. You can also specify the color of the node if you wanted to fill in a color. So you can format them to look a specific way, and we will work with that today. Okay. So you can use attribute, edge, graph, node, and then you can specify what each node would look like, what shape they will hold, and what color do you want to fill. Okay. Now here it talks about subgraphs. So if you have subgraphs, it would receive the attributes from the parent graph. So when you use the term subgraph or the keyword subgraph, that would carry over the attributes. Okay. And here it talks about character encoding. I've seen university requirement that they require students use this to map out their data structure or their program, etc. So you program the structure of your program. And so this is a very useful tool for that. Okay. Let me see where I can find a PDF for you. I think I put it in there. So the guide itself has the details in how you would be able to set it up. So it gives you an example like this. This is if you wanted to draw this little small graph that's shown below, right? So you have the main that's going to go to parse. And keep in mind that it's going to be one node to the other. Even though we see main to parse and main to clean up, you cannot put it into, so unless if you put it into one line like this, it's going to be hierarchical like this. Okay. And then you can have it all map out to a specific way that you want it to look. So that's an example of directed graphs. And then below that, it shows you how you can do attributes. Okay, you can have the shape. If you say box, that's going to give you a rectangular. Okay, you can have it weighted. You can have it styled. You can have it colored, etc. Okay. So if you ever want to program a flowchart, you can now do that. So in this one, it shows you how you can use polygon, how many sides of the polygon, the color, right? And so we will practice some of this shortly. Okay, so now let's go back to our assignment. So to use this, what we can do is we can start with a very simple graph, non-directional. And here I put in the link for you to download, and you can install it on your system appropriately. If you use Mac OS, go to that section. There's some short instruction on how to use that. Right? If you use Windows, we talked about how to install it with the executable or the zip file. So mainly when you write this, you need to use a text editor. And so I have a picture of mine shown here. Okay. So what I did was I created a folder on my desktop, and I'm using Windows 10. And in that folder, it's called Graph. And in that folder, I save all my dot file. And with that, when it generates the image file, it's going to put it in that folder for me. So you should organize it and keep it in a directory. So for example, in a network environment, you might have a lot of different domains. Okay, and so you can set up a directory for a certain area of your network physically, right? To really control the inventory and the status, manage those type of systems. And so that way you can create these files. So that way it would map out, right, all your nodes, and it would store it in that directory. Why is that important, right? For the purpose of maintaining our inventory, maintenance purposes, for security reasons, right? We need to ever go back to take a look at that, we can, for audit reasons. So in a text editor, if you use Notepad like I have, you can simply open up a new file, and then you would be able to write it. So you can name it anything you want here, but the first keyword is graph. You have to use graph, right? Remember that that is going to instruct the system, or GraphViz, that we are going to graph whatever's enclosed in the curly brace. And so here I basically tell it to graph company network, right? I have HQ connect to branch 1 and HQ connect to branch 2. And we can expand further, but that's all I want for this exercise so you can see. And to connect that's non-directed with the edge, what you can do is you can have a dash dash. Make sure we enclose the curly brace. And using command prompt, you can say .v to check the version of your dot. Okay, and it tells me that I'm using GraphViz version 2.47. Okay, and it tells me that here is the configuration file. So no need to space it out. It will space itself out nicely. Yeah. It is a little bit more forgiving with this, so it would actually just default to the length of the edge that's set up by default, and then the default node is going to be the circular, unless you tell it to box. Okay, so if I wanted to, for HQ to be box, then I have to specify that that's a shape that I'm going to use. So as I mentioned earlier, I had set up a folder called graph on my desktop. Let me show you where that is. Okay, so on my desktop, I have a graph folder. Okay, and in that I had saved my dot file, even though Microsoft thinks that it's older because it looks like doc, right? And you can also have a .gv, which is for GraphViz. Okay, so as I have that folder, I wanted to change my directory to that folder, because if you save it on your desktop, you have to change your directory to desktop, right? And then I have my folder in graph. So wherever you save your file, you have to navigate to that through command line. Okay. And on Linux, if you're using Linux, if you just save it, it saves it to home. So make sure that, and in some cases, you have to put it in the proper directory so that way the program can access it to open it up. Okay, so on the Windows side, wherever you save your .dot file, that's where you're gonna go. Okay, So once I'm here in my folder, what I need to do is I need to be able to run the command, okay? So when you save your .dot file, make sure that it is in a location where you can navigate to it through your command prompt or your command line. And then when you execute it, you would type this in. And when you read this command, what is it doing? It's using the dot executable. It's gonna use this option to generate a PNG from the .dot file and converting it to an image file. Okay. So if whatever the extension of the file that you use here, there are a few options if you look at their documentation. So TPNG means that it's gonna translate that to PNG. If you use TPDF, then your file extension needs to be PDF. Okay. It also can make SVG. Last week we talked about using SVG when we're trying to do the charts, right? So there are some options in how you want your image to be. So again, right, make sure that you save your file and then change your directory to wherever that you save it as. And then what you need to do is you need to put in this command, right? And then it's going to be able to generate this. So how do I know if it's done it? Well, I can go and open up the image and it should show this. Okay. So when you finish with that, you can put in the screenshot of your dot file and your output. And we can keep things by default. Now, do not use space like this, okay? Because if you do, it's going to do HQ branch 2 as a separate node, okay? So the white space in the naming of your node is going to make it think like it's a separate node in addition to branch. So we wanted to, if you wanted to keep the name together, like branch 2, make sure that there's no space between branch and 2. Any questions? All right. And so this opens up a Word. However, this should be in Notepad, right? So that's simply your code. Okay, so next we are going to practice using directed graph. And so you would see something like this in a network environment. You would have a switch connecting to another switch, that switch connecting to another switch, and switch 2 is connecting to a fourth switch, and so on. And then some switches are connecting to a router. Okay. So for exercise 4, you would start with having digraph. That means that we're going to tell it to do a directed graph. And in the notes, there's some example that you can use there. But in the author's example, he's he's using Linux. So there's some slight difference in the command option, but mostly very close. And then you can name your network whatever you wanted to name it. So I decided to just use my network, kind of like the example. And then here is where I can specify how I want my routers and switches to connect. And again, like what we talked about with the directed graph, we're going to use a dash and the greater than symbol here. So we're saying that switch 1 is connected to switch 2, switch 2 is connected to switch 3, and so on. And then all I have to do is make this save as, right? And then I wanted to make it as a dot file and put it where I could find it. So after I had saved it as a dot file, I again would use the command dot. But in this one, I'm going to generate a PDF. So I would do a -t PDF and then whatever the file name that I use with the extension. Okay. And then we want to output, O is for output, right? A PDF file called ex4. So after you issue that again, make sure that we are in the right directory. Otherwise, it's going to throw an error on your command line. So after we issue that command, we would see something like this. And this could be pretty fun, right? You can be very creative in how you wanted to graph things out. Now, in this one, I didn't touch on weighted graphs, right? So in networks environments, we would put the weight in on the edge to specify priority, critical level, etc. Okay, we simply just do a regular simple graph and a directed graph as examples so you can see. But you can definitely set it up to have weights, right? You can do a lot more to the nodes to distinguish them. Any question? And so in network design and security, a lot of times we go back to the topology and we would see, right, which area is lacking in, for example, physical protection or even the logical, like how data is flowing. So in this case, you see that switch 1, right? There's some redundancy in this, but not so much, right? And then everybody gets sent to router 1. So on a small scale, you would see that, okay, this might be your gateway right here. And then that would be connected to, if it's a gateway, then it's connected to your ISP. The only two that requires more redundancy would be your S4 and S5 right here, right? Because if they go down, this whole, so if 4 goes down, your S5 is toast, right? Because data doesn't get sent from other segment over. but then we have an alternate way where switch 1 would be here. So from an attacker standpoint, when they are skimming and looking and sniffing through your network, they're going to look at the flow of your devices, right? And they're going to go for the one that has the largest weight in the target. Meaning, if I was the attacker, I would attack switch 1 and router 1, right? Single point failure here. This one, distribute information to the rest. So that means that something is connecting to it that must be essential, like servers, right? So in the security design, we would then think about maybe, right, possibly implementing security barriers here in this area, right? And then we would have external barrier, okay, possibly setting up some DMZ area to kind of isolate the rest. So network topology speaks 80% of security in a network and in a business operation. It's going to take up, it's a big involvement in security. Any question with number 4?
Right. Can I on the doc? I just copied and pasted the graph.
Yeah.
Yeah. Well, the one from the problem. I guess, and then I got something different, which I think.
Yeah. So I think I have a double R1 here. So
Yeah.
yours might have this, right?
Yeah. Okay.
But actually, let's see. I might have typed it a little bit different, so that's okay. Yeah, S4 switchback. So you would have a redundant with S4 with S1, where mine looks like I have redundancy with R1 and S1. So yours might loop back over here.
Mine, well, with having S4 to going
S1.
S4 to S1, it ends up just being like as the graph was like basically different. I thought there was a lot more difference between what was on the document and what you had. I thought I was trying to compare, but if that's the only difference, then
yeah, that's the only difference in between yours and mine. Yeah, I wanted to make it a little different in you guys so that way you can see. Yeah, so I have the R1 here instead of the S1. Yeah, so Seth puts it in.
So just in case, do we do the one on the document or?
Yes. Yes. And that's okay to be different, right? Because, yeah. So this is what Seth put up, and that's what it should look like. So now, okay. Right, from a security standpoint, this is the weak area because everything comes back here. So that will be, this is the first target. This might be a second target because if I cripple this right here, it doesn't get to the router. I cripple S4 and S5, it doesn't get to the router, right? So what I need to have redundancy is to make S1 connecting to R1, because in the case that this side of the network get brought down, or sometimes they fail, right? Devices would fail, then you have an alternate way to get to your router. So when you look at this design, you should look at how the information is flow. Well, this goes to S1, and then where? It goes to S2. S2 gets sent back to here or here and down here, but shouldn't it be that we should have another line connecting from switch 1 to router 1 as a secondary, right? So that simply is just a very small step in configuration and a physical cable connection. Now, the downside in that some of the routers only have they have very limited, in and out connection. They usually just have maybe one out and a couple of ins. Okay. So we have to consider what kind of router we have here. And if we do have an additional Ethernet connection or serial connection, then we would be able to connect that, right? Because if this is crippled, then nothing gets to the router. Okay, if this is down or this is down, then nothing gets to the router. So you want to have redundancy in a network design. So when we look at this, what does that tell us, right? What's the flaw in that? So, and then, for the companies that have more money, right, in a larger scale, then we wanted to have an alternate route, right, a secondary router, or thousands more if that's, if it's a very large company. Okay. So how do you fix that, right? Once you fix it, then you can just chart it, just graph it where it flows out here, or maybe if you have router 1 with its peer with router 2, you can connect it directly, and then S1 to R2, something like that. Network design is one of my favorite things to look at, because I can look at it and I can tell you, right, where your flaws would be. So when you rank this from a security administration standpoint, what they're going to do is they're going to rank it based on the critical, right? So you can look at your information flow, your packets from a certain segment and how it flows in and out. So this one is handling outbound, right, for your egress. So, your egress. So what will happen is, right, we probably need something inside to protect our information that's internal, that's going out. And then we should have something that's screening at that, right at the barrier, at the boundary. Okay. So do like what the exercise required, not like what my diagram shows. I just wanted to make it look similar so you can see. Okay. So now you know how to use GraphViz. Let's do another one that's a little bit more fun. Let's do this one. Use your text editor to create a directed graph with the node shapes that includes the following node connection: R1 to S1 to S2, R1 to S3, S2 to S3 and to S4, and then S4 to R1. Okay, you can use any shapes of your choice, right? The example I pulled from the PDF document, so you can see how that would be. Okay, so when you do the second level arrow like this, that would fit more for the first. So that means that router 1 connects to switch 1 and switch 1 connects to switch 2, or you can do it separately, right? You can do R1 to S1, S1 to S2 in 2 separate lines, however you want to do that, but you can have it at level like this. And then for you have to declare, right? You have to define the attributes of your objects, your nodes, okay? So what does R1 look like? What does S1 look like? What does S2 look like? So we want to save, I'm sorry, I'm dyslexic sometimes. GV. So save your file as ex5.gv, and then you can use the dot to generate that and see if it goes. Okay, so you should have the GV, which is a GraphViz file. And then we want to make sure that we would use the dot to generate the PDF. So ultimately, I use yellow, right? So I have a polygon, inverted triangle. You can use triangle. You can use box if you want. And then you can use the color of your choice. So these are my output, and then this is my my GraphViz file. So I have R1, S1, S2, R1, S3, S2, S3, S4, S4 at R1, and then I specify what the router looks like, what's the S1 looks like, right? What's the S3 looks like, what's the S4 looks like. So there's a correction in the, make sure that it's GraphViz, and then GraphViz there, okay? Sorry about that. So when you do this, you using GraphViz directly, okay, like an application. The only thing that's different than going through graphical user interface is you create your script, your script for GraphViz, and then you run that script, okay, in compared to using the UI. But a secondary way that we can do this is with Python, okay? That will be a more of an indirect way to create graphs, or at least view. Now, when you're using Python, if you're using an IDE, make sure the IDE also see the packages, because if you don't, it's not going to know. Even if you install it, just like what we talked about with all the other ones like tk-enter, Scapy, all of the other ones. If you use an IDE and you don't bring in the packages, the IDE will not be able to link, right, that package to the application that you're using to write and run your script. And some IDE, like in my case, when I use Tawny, is limited, okay? Now, if you use Terminal and Vim, or your text editor with your terminal in Mac OS, that's fine, right? You can edit your script and write your Python script, save it as a .py, right, to a certain directory that you wanted to run, and then be able to execute it, okay? You would have it under USR, bin, etc. So just keep in mind that when you write the Python script, make sure that your IDE has the package. And if you're not using the IDE, make sure that you save your py file in the right directory so it can execute. Any question with this exercise? So the color and shape, you can come up with your own as long as it's visible and easy to read. So keep in mind that, sometimes people can't see a certain color, and then make it easy and simple to see. That's important. Okay, any question with 5? So the lab will have some of this element. We are gonna experiment with this, and also we're gonna tie in some of the other components, the other library and tools to really incorporate for network monitoring this week. Okay, so for 6, it says you are going to use the exercise 5 criteria, but in this one, you're going to write a Python program or script to use GraphViz module to create directed graph to display the source of the graph. And we can display it directly into our terminal or command line. We can provide the screen capture of the Python script and output. Or if you're using an IDE, you can show it the display in console. Okay, so here I provided a link to the GraphViz guide, which is different than their home page information that you saw earlier. Okay, so it talks about how you need to pip install GraphViz, but we have to import it in. And after installing GraphViz, make sure that the bin subdirectory containing the layout commands rendering the graph's description. So this is super important. I was playing with this last night just to troubleshoot some of the built-in functions or method for Python. So dot, circle, and needle, these are the three tools that you need to render a graph. Okay, so when you're using render method, like what you've seen in the previous exercise, what you see is that you have to make sure that this is containing in the layout. Meaning what? You have to make sure that your system path specify each of these. Okay, otherwise it doesn't understand that. What are you trying to do? Are you trying to use dot, or are you trying to use circle, or are you trying to use needle? Okay, so make sure that this is on your system path, and you can navigate to the bin folder or directory and see if those executables are there. So that's one of the things that we want to pay attention to. And we also wanted to look at some of the details that's given to us about using Python. So with the dot language, you can make it for undirected and directed graph respectively, right? They have the same API. So if you're using directed graph, you would say from GraphViz import digraph after you install GraphViz. And then you would declare your object. You can call it anything you want, right? And then the comment that will just be, you know, kind of like a label for that graph. And then, so you can look at those example and kind of see. Now, what we can also do is we can use nodes and edge, right? These are the methods or edges to be able to draw the node and the edge. Okay, so instead of using GraphViz dot file, right, like what we created earlier, we are going to bring in the directed graph, okay, subclass, and then we are going to create an object and then use that object to access the methods, right, from that library, like node and edge. Then now, okay, we can simply print right? The source, which it's going to map it out in your console when you print that, or if you use command line, it's going to show that on command line. Now, if, like I said, if you use render, which you would see later on, you have to make sure that you link your system path accordingly. Otherwise, it's going to throw an error. Okay. So I'm going to show you. Here's mine. I was going to do something else with source. That's why I have it imported there. But you can also, I wanted to mention that you can also use source. And then you can use source to create what you would see with nodes and edges as well. So that would be another option. So first, what we do here is we added a comment, exercise 6. And then if you wanted to make it a PDF, you can also format it as a PDF file. And then now I didn't render it out to a PDF file, but you can also use digraph to format it as a PDF. And then I created the nodes. And then I created the edges. Okay, in this one, you cannot use the third parameter. The third parameter is going to be considered weight. So if you're trying to add the weight to your edges, you would then have the start and the destination node, and then the third parameter would be your weight. So I would then check out the output so I can do a print and then pass to the source. So it's going to grab all of this and it's going to draw the arrow. Okay. Now, earlier I mentioned that you have to set up your configuration for your IDE. So on this one, I'm using Tawny. So I just got to make sure that I click Tools, Manage Packages. I got to bring in GraphViz. Okay. And if you don't have it installed, make sure you install it. Okay. So what you would see is what would go into a dot or a neato or a circle file, right? Which is your source. Any questions? And you would see a similar example from your notes. Can you show an example to set the circle as an environmental variable? Okay. So in Windows, I haven't tested the circle one, but okay. You in your user, if you already have the path, like what I told you earlier, right? Like this, if you have this path, the user path is the same. Okay. Now in here, you would click this and then you would click this, the new button, and then you would browse to the directory. So that's under C, program files, GraphViz, bin. But you have to put in, let me check if it's there. Hold on one second. Yeah, so this executable needs to be there, right? So that will be circle, and I think it's exe. Yeah, exe. Okay. And then what you have to do in your command prompt is that instead of so on Linux you can do the output like this, okay, but you can't do that on Windows side. That's a slight difference I mentioned earlier. But when you write your commands out for circle, instead of the dot in the front, you would use circle, and the option's going to be very close, very the same, right? You would have TDF or, you know, TNG, etc. And I think they have, let me find the instruction for you for that. Yeah, I didn't like the way that they document this part right here. It was kind of confusing. Command line usage. Set output language format. So here it shows the format. Yeah. So position canon dot plain text. I'll test it with the circle. I'll show it to you on Wednesday, Michelle. I just want to make sure it works because, you know, always in the documentation, it's not very clear. It just, you know, it shows you can use it with Cairo, but I just want to make sure that I test it and get it working. I'll show you. Okay. So I know Nido works with but I haven't tested with the other one. Okay. So often that people use dot or Nido, but yeah. So importantly that we wanted to link it with the path, right? And then also if you're using IDE, that's not done, right? You set up your system path, but remember that your IDE has its own path, and then you need to be able to manage it, okay? So you would be able to go into options and set up how you wanted to link that to your IDE. So it gets a little crazy, right? Working with this, but if you wanted to run this .py in a command line or in terminal, that will probably be the easiest. Instead of that way it would revert back to the system path and be able to kind of use the system path, okay, as terminal or command prompt is part of the OS path, your system path. Okay, any question with this one? Okay, so that's 6. And then I screenshot that one just in case so I don't forget. Okay, so let's talk about the next part. So here in the notes, it goes into how to print, right? So you can use this example for number 6. Slight difference in the command. So what you can do is you can use the script to write out what you would see with the dot language. So link layer discovery protocol, it is a layer 2 neighbor discovery protocol. It allows devices to advertise its information to the neighbors or the peers, like routers to routers, switch to routers, etc. It's going to say, hey, this is me, right? I am your neighbor, send stuff to me, I'm available, etc. So now in some of the later tools that you would see, like Netflow for Cisco, it would use this type of protocol to really identify, right, like how that would be connected. Now, if you're using the earlier library, like what we talked about with pexpect and Paramiko, you can also do that. You can automate with Ansible Playbook, which a big chunk of the chapter, it talks about how you can automate that so you can reuse it, right, instead of having to create from scratch every single time. So Ansible allows the system to query other systems, right, as tasks. But we got to make sure that this protocol is enabled if we're going to use it, just like SNMP, right? When we use that protocol, that ties to a service and a port, so we want to make sure that that's enabled. Okay. So you need to configure that by enabling it. Now, the author, he mentioned that he wants to first establish a configuration file, the host file, right, for the Ansible, and he used the Ansible to kind of update the information for the 5 routers. Okay. And so that's what you see here. That's a playbook. And what that does is it automates, it turns on LLDP for all 5 routers instead of going through each one, right? And then be able to turn that on. See how you have the enable LLDP service here in the task? Okay. So what he did was he created a group called devices and a secondary group called edge devices. And this is in the host file. Okay. Then he create the playbook, right, to update those devices by enabling the LLDP service. Then he would run it, and that with the Ansible. So with that, we would have all these routers, right, configured for LLDP. And here by default, it advertises every 30 seconds. And you can specify that. You can tell it how often you want it to advertise. So if you don't change anything every 30 seconds, they're going to tell each other, hey, this is me, I'm here, connect, right? So that way we can verify if they discover each other. So this shows us that when you use LLDP on that, right? When it sees another router or another device, what it's going to do is going to hold the information about the other device. Okay. Especially the interface, right? The connectivity, the port, etc. How it can talk to the other device. So on the second part, he touches on how you can create a directory called TMP. And then with that, we can add in a playbook to show, right, LLDP neighbors. And then it has 3 tasks. First, it's going to show the neighbors. Second, it's going to have to show the output. And then it's going to copy the output to a file. Then we can later use that file, right, to graph. Okay, so you can automate this, create a file, and then take that file and convert it to a visual element. Okay, and that's the whole point in this particular step. Okay, so it's going to do an output text here, and then we're going to take that output text and graph it. Okay, so first it's going to list, right, each of the file for each of the router. Then when you open up that one of the files, right, it's going to tell you about that device and its neighbors. It's kind of like how you go down the street and you ask a person that lives in the house that who are your neighbors, and they would tell you all the names of their neighbors, right? It's exactly what that router is doing. Okay, so each text file holds the information about the adjacent or the neighbors. Sometimes it doesn't have to be adjacent, doesn't have to be a direct neighbor. Then after we have that, then we can write a Python script, and we would use that Python script, right, to be able to create some kind of graph structure, okay, directed graph. And what we can do is we can specify that we're only going to look for a certain interface to graph, right? Like if you're only going to look at that port, that connection, because it represents bandwidth, right? So that way you can graph it and you can see the route, how it's connecting to its neighbors, and with that particular bandwidth or with a certain size of bytes of traffic, etc. So you can filter out some of the elements. You don't have to graph everything because it's going to become crazy if you do, right? We can actually set up, like here, what you see, he's putting together a pattern, and he's going to use that pattern to graph out the 6 routers. So when you parse the result, okay, this is the devices for that particular PY file, right? We need to start the edges and the nodes for each. So it will populate that list from the text file that we created. Okay, then we set up the edges. And then we would have a for loop because now it's a group or a list. And then from there, this is look very similar, right? That's what you see with the dot. Okay, you would have something like this. See how they have redundancy in this, right? You got outbound, so you have egress, you have ingress. So in and out, Okay, and then in between. Now, in a larger network environment with a lot more routers, it's going to be more crazy than this, right? We know that this is just simplified so you can see it clearly. So sometimes it will be helpful if you have it color coded, right? So you would have a certain route color coded so it's easy for you to identify. Okay. So here with this one, you can see that we would take the text information that we got from those text file, and then we would be able to populate it. Okay. And then we would then output it as a GraphViz file, and then you can convert that to an image file if you want for records. Okay, so let's answer the next question. So for 7, it asks you, what is the purpose of LLDP? It is a layer 2 neighbor discovery protocol that allows devices to advertise the information to their directly connected peers or neighbors. And again, if you're using this protocol, you have to initialize the service, right? But keep in mind that not all devices come equipped with LLDP. So you want to make sure that you check the devices that you're working with, making sure that that protocol is available for that type of service. So in this, what we would see is that you can use technology, different type of technology to really monitor your traffic flow. Okay. And we mentioned that Netflow is one of the options, and Netflow is Cisco oriented. Then you have IPFix and SFlow. And these work with Python. Okay. But keep in mind that even though Cisco produced Netflow technology, it doesn't mean that all their appliances are Python equipped. And if you ever work with Cisco documentation, it is crazy, right? Commands don't work, different versions of OSI. So there's not a very streamlined uniform process in their documentation for some part. So there's some challenges with that. Okay. However, using tools like this would, for some of the basic information that we're talking about with monitoring, because packet stuff is going to be the same across all appliances, doesn't matter which vendor, right? That's something that it's standardized. Traffic information, TCP IP suite is standardized. So you would have standardized processes that's incorporated for understanding traffic. Okay, so the 3 types of technology that we would see using for flow-based monitoring would be Netflow, IPFix, and SFlow. And we touched a little bit on Cacti last time, right? Cacti is a full-blown, with interface tool that you can use. And in this chapter, it talks about ntop is the other one. Okay. So before we do number 9, I wanted to show you that. So on page 12, it goes into flow-based monitoring. And the 3, right, is often referred to the main 3 here, and it talks about how that's different. So your IPFix is similar to Netflow version 9. And I think the author uses version 5 to illustrate because the updates require additional templates, which makes it a little bit more challenging to work with. So the older version of Netflow is a little bit more simplified. So with IPFix, you would see it similar to the version 5 of Netflow. And then for SFlow, with the SFlow, it does a sample of packets. Okay. And you would see this being used like with ntop. I'll talk about ntop. Okay. So here it shows you how you can create a Python parsing file for an HTTP server. Remember what I said earlier, there's processing GET with HTTP. So here what we have is we would turn on the HTTP server service, right? And then in the Python file, we would import in request and time because we wanted to monitor like when it's sending the request and when it's replying. And then we have a while. And then we would have the destination server IP and the port. And this is often used as 8000. Some company, they would use other port number. So server, you would see that they would use the higher range port. That's uncommon, right? But for this would be 8000 because 80 represent HTTP and 8000 is the server that's servicing HTTP. And so we would want to print, and then we want to pause, right? The HTTP get every 5 seconds. Okay. So when you run that, you're going to look at something like this. Now to test this, you have to have a live server, or at least that service turned on with the proper IP. Otherwise, it's going to throw error, right? Because it can't execute it. So we would then need to initialize the server. So when it listens to the request, this is what you would see. So it shows the timestamp and which system is requesting or getting that information, I should say. What we need to import request module, yes. Now keep in mind that this up here, okay, this is for the web server. This script right here, HTTP GET, is for the web server. Okay. So the IP address that you would see, because the server is gonna respond to that GET. So, and with the request, you would have appropriate command that's gonna be included for the GET process. Then on the client side, right, it's going to submit 3, like the GET, and then the server is going to respond back. So when we look at traffic like on Wireshark or Sniffer, you're going to see this. Whenever people are surfing the internet from the company, or I call surfing, I'm so dated, visiting a website, right, then you would see this. That's basically, you know, when they type in a URL and on their browser and connecting to that web page, they have to go through the process like this. Okay. So we can specifically use the script to kind of look at that, right? We can filter out just that particular type of traffic packets. Okay. All right. So let's answer the next one. We're now down to 20 minutes. So write a Python script to send HTTP GET to web server 10.0.0.20 every 5 seconds. Short, sweet. Import request, import time. While true, we would have request.get server IP and port. We would print. We would have the time wait for every 5 seconds. So if you wanted to change the wait time, you would do that here, right? And then if you have a different server, you would do that here. Or you might have a list of of web server, then you would have to set up that list and then use a for loop and then nest it with the while. So once we have the file, we would then save it as a .py, right? And then you saw in the example in the textbook and the notes, he runs that, right? And we would be able to test it more closely if you, and you know, simple thing, you can put up an Apache server, you can put up an Ubuntu server and turn on the web services on it, and then you can test it. If you really want to simulate this and see if your script works, right? Put up 2 virtual machines, run it from one connected to the other, or use the client, right? And then see if it's going to be able to connect it to that web server. But the challenging part will be setting up the web server to be able to communicate. So internally, we can set it up in the same network segment first to start, because if you don't have a public IP, you cannot, right? You cannot connect it from the outside. And if you wanted to do it from home, if you have that type of service, you have to do port forwarding on your router and then all these other things. So internally, you can set up 2 virtual machine connecting and then enable that port. So that probably take up like the big chunk of the work. So the scripting part is pretty straightforward. So any question with number 9? Okay. So you can look at the example on page 13. And then here it touches on looking at how it would do a flow export with version file on Netflow. Now in the next part, it talks about socket instruct. So when you work with parsing from Python, sometimes you have to incorporate socket for specific type of protocol like UDP. And this will allow you to listen to the UDP traffic. Okay, so here it shows you the example on setting up the socket for UDP, which is diagram right here. And then how you would set up the IP address for the bind and the port information. So in this, when they loop this, it's actually just retrieve information at 1500 bytes at a time, so you can specify the size that you want to receive, right? Because it can be a lot each, and you don't want it to overflow. So we wanted to make sure that we can have enough storage to accommodate. So as it loops this, because it's going to keep going, right? And then eventually when it reaches the limit, we can also add the script where it overwrites the original. So here is where we would specify the limitation with the size. So the majority of, the other traffic is going to be non-TCP based. It will be UDP, and you would have a mix. So we can also monitor UDP or listen for UDP. And because the attackers do, right? They look for UDP traffic so that way they can take advantage of UDP traffic with poisoning and such. Okay, so here it shows you a little bit of information about bytes and header format for user datagram. If you study for Network Plus, you have to know the header format for a different type of protocol, or Cisco that is too. Okay, so let's talk about yeah, so the rest of this is just parsing with Cisco, and then the structure. Let's talk about ntop because we're coming down to like the last about 10 minutes. So ntop traffic monitoring is an open source tool. It has a graphical user interface. Ntop, if you visit the link here or the link there, you would see. So if you go to the home, it tells you what it is. Okay. This you can do web-based traffic analysis, but this is high speed, so it uses ntop ng. This is now incorporated with Kali, or it's been incorporated with Kali, I shouldn't say now. So you can definitely use Kali with this, but Kali uses more of the terminal side. So here you can find the type of products. So it allows you to monitor, it allows you to probe, it allows you to use Netflow. So there are some tools incorporated in this already. If you wanted to do deep packet inspection, this is a good tool to do that. And it's designed to really look at, distributed denial of service type of traffic, so you can have prevention. Therefore, you would see that here. Now, keep in mind that some of their tools are commercial tools. Not all the tools are free, of course. The tools that are free are what you would see, like the ntop ng, or ntop png, I should say, and some of the probing capability. And then if you want more of an elevated, more bells and whistles in that, you can take a look at what they have to offer, right? That's how they make their money, is to release some open source stuff. So here, if you wanted to use nprobe, right, this is an extension to some of the tools that we talked about. So that will be the probing capability with Netflow, okay? And then recording traffic, so it keeps all the logs, traffic analysis, and then of course sniffing. Now, so by default, ntop web interface listen at port 3000, and it probes using the UDP port 5556. So if your organization change up the port, right? But if you use the default, that would be 3000 for listen, web interface listen, and then probing at UDP port 5556. And in Linux, you can do a sudo apt-get install ntop. You don't have to use the interface. You can use terminal base to with ntop, so the traffic result, it's going to give it to you like this. Okay. So it organizes it, hosts, sent, received. I feel like it's a little bit better in display compared to other tools. You know, and you can also filter down to the busiest system, which is what they call the top talkers, the one that receive the most traffic. And what it does is it categorizes it by the transfer rate. Okay. And so you can study your trend doing analysis. So the network analysts and the security analysts, they look at this, okay, for live monitoring. So for the next question, let's answer that. Why should you use ntop? How do you install it? Right, ntop is used to analyze network traffic. We would use ntop. So ntop, sorry, I was sleepy. NG is high-speed web-based network analyzer. Installation would be sudo apt-get install ntop in Linux. The port that it's listening, we set that web interface that will be listened on port 3000. For probing, it would listen on UDP port 5556. Now to execute, if once you install ntop, if you create the ntop script, like a Python file, what you can do is you can simply run the script with the URL or the IP address and the port number. So for number 12, you would say run script by using HTTP, the server address, which is 172.16.1.173, the port number, which is 3000 because it's web-based. And then we would tell that it's Python and the file name that we created, which is ntop-test1.py. Okay. Any question? So I only have a few minutes left, but you would be able to check that out after here. You know, this section, it talks about extensible to ntop, which is Python, right? You can embed Python in there. So, and keep in mind that it's under this specific directory on the web server. So it's under ntop/Python. So it's under the Python directory in the ntop directory. And there are 3 modules. So you have the ntop, which interacts with its engine. Then you have the host, which is for specific host information, IP, etc. Interface, that would be for the local host interface. And here is where you can find the answer for the previous question that we just touched on page 19. Okay, example of Python script. Okay, note import ntop, interface, and JSON. Okay, because it's web data, JSON. All right. So the output for the interface is going to look like this. Okay, from that script that they wrote. Okay, so SFlow, last few minutes. So SFlow stands for sample flow, and it was created by Inmon. And so the later version was more standardized for RFC use, and SFlow work with Arista, right, VIDA, and other type of networks like A10. So you see those in data center. Cisco also support SFlow in the Nessus, but generally not supported in the iOS area of Cisco. So keep in mind that their more modern line, which is Nessus, which is you got the OS X side of the house, or the NOS X, I should say. Okay. So here with Python, you can use Python with SFlow tools, okay, for devices. And basically it talks to the device API. Okay. So that allows you to look at how you can use it. So here it shows you how you would be able to install it. Okay. And you need to install it on the device. Okay. So the installations. So it's a little bit different than the other one. Now, what you care about, interested about, is this part. Okay. So the script that they created here is to use the SFlow tool, and then it's supposed to read the information from the device and report about what they call the agent, which is the host, the connected host, right? Like IP address. So after they run this, this is what you see. That they have flow received from these or that system. Okay, so you would import regular expression, system information, and then be able to do the read line for the agent. And then there's some additional information about using TCP dump. And TCP dump is often used with Linux for traffic. Now, one important thing before I send you off, right, for the afternoon, this particular tool, because in Mon, when you use the Flow RT uses Java. Okay, so, and not all the devices are Java equipped or can handle Java install. So just remember that you need to have Java for SFlow RT, which is different than SFlow. Okay, so they made different tool sets because to work with different API, right? As you would see down the line, you would have operating system that's equipped with these devices that would have different plugins. And with those plugins, right, they would be able to adjust the tools. So we can use SFlow RT with the proper plugins to be able to monitor that particular type of device. Okay. So here, okay, it shows you what that would look like. Looking at the port. Okay. For those systems. I think that is about it. So the output on SFlow RT alone, that would look like this, but you can definitely use Python extension, you know, component to run it with it, to run with it. So for 13, the benefits of using SFlow over Netflow for newer devices, it is scalable, and it gives you real-time statistics sampling, and they talk about competition in that, right? But really, when we're looking at how to look at network traffic, we would look at real-time statistical sampling and scalability. So how fast is your network growing and is it going to scale? So this would probably be a better choice, especially for a very rapidly growing data center. Okay. And that concludes my session for today, which brings us exactly to 4 p.m. Let me know if you have any questions. Thank you for attending. Thank you for typing in your name. Don't forget to type in your name before you leave. Have a wonderful afternoon. I will see you on Wednesday. Right, don't
Professor?
Yeah.
For number 5, it has to save the file as a .gv file. I couldn't save as that. It keeps saving as a .gv text file.
Oh, how do you write it? Do you write it using Notepad?
I use Notepad. I use the same Notepad for when I save as a dot files, and it works just fine.
Yeah, so when you do save as, right, go here, make sure you choose all files, and then you would do a .gv. Okay, it should take it. Because if you leave it as, and when you do save as, and you don't if you don't change this part, it's gonna put the .text at the end. So make sure you choose all file here. And then do GraphViz file.
No, it's still saving as a text document, but the thing is I can still create a PDF file with the graph.
Yeah, it should be able to read it because it's still a text document after all, right?
Mhm.
But this file is specifically used with GraphViz, right? It's for GraphViz.
All right.
But it can use text file like what we've seen with the dot and txt in the example in the book. But when you save it, I think if you keep it like this, and even when you put in the extension, it's going to put the .text extension following it. So when
Okay.
you do save as, make sure you change it to all file, and then make sure that you delete the file extension and then retype the file extension and click save.
All right. Thank you. That's all I have.
Yeah, no problem.
Take care, Professor.
Okay, bye.
Thank you, Professor.
You're welcome, Cynthia. Have a good afternoon. Bye. Yes,